Hello students, welcome to lesson 18 on trigonometry. I hope you are all doing well. Good. Now, in our previous lesson, we looked at reference angles. So we defined it and then we learned how to identify or determine reference angles when an angle is drawn in standard position. So we solved some examples and then I gave you an assignment. I hope you've all done the assignment. Good. Now we'll begin our lesson today with solution to the assignment. So let's look at the question. Now we were to find the reference angle of the following angles. So 30 degrees, 120 degrees, 240 degrees, and 300 degrees. Good. Now, before you tackle such a question, the first thing you have to note or take notice of is the quadrant within which these angles will fall. So 30 degrees will fall in the first quadrant when drawn in your standard position. 120 degrees will fall in the second quadrant, 240 will fall in the third quadrant, and 300 in the fourth quadrant. So after identifying the quadrant, it will be easier for you to know the reference angle. Right. So let's see how it goes. Good. So for 30 degrees, the angle is 30, but its reference angle will also be the same as the angle itself, because the definition of reference angle is the angle formed between the terminal side and the x-axis. So the acute angle formed between the terminal side of an angle and the x-axis when an angle is drawn in standard position. So with A, the reference angle will be 30 degrees. The reference angle will be 30 degrees. Good. Now with B, the angle was 120 degrees. So this is 120 degrees. Now, to get the reference angle, you have to subtract the principal angle from 180 degrees because the angle here is 180 degrees. Okay, so either you subtract the principal angle from 180 degrees or you determine the angle that must be added to 120 for you to get to 180. I hope you get it. So the acute angle between the terminal side and the x-axis is 60 degrees. So you can get the second one also by subtracting the principal angle, which is 180 degrees the principal angle, which is 120 degrees from 180 degrees. Okay, so what it means is that in the second quadrant, to determine the reference angle, you have to subtract the principal angle from 180 degrees. So you are going to have 180 degrees minus 120 degrees, and this will give us 60 degrees. Good. Then for the C, the angle or the principal angle is 240 degrees. Now the reference angle is the acute angle from between the terminal side and the x-axis. So here the acute angle here is 60 degrees. Now we get the 60 degrees by subtracting 180 from the principal angle, because when you add 60 to 180, you get 240. Okay, and that will be the acute angle between the terminal side and the x-axis. So here R will be equal to 240 degrees minus 180 degrees, and that will give us 60 degrees. So in the third quadrant, to get the reference angle, you subtract 180 from the principal angle. Right, and then the last one, the principal angle is 300 degrees, and we are to find the reference angle. The reference angle is the acute angle between the terminal side and the x-axis. So here, the angle here is 360 degrees. Okay, the angle here is 360 degrees. So we have to subtract 300 degrees from 360 degrees. So here our R will be equal to 360 degrees minus 300 degrees, and that will give us what? 60 degrees. Okay, 60 degrees. Good. So students, this is the solution to the assignment. Now you cross-check it with yours where you were not able to get it. Make sure you take your time to understand it, and then if you are able to do it, clap for yourselves. You've done well. Good. Right. So now let's move on to our main lesson for today. Now our main lesson for today will involve the knowledge of reference angles. Okay, so we treated reference angle first because we will need it in our subsequent lessons. So don't forget the knowledge that you've just learned. We are going to apply it in our lesson for today. Right, so today we want to look at the signs of trig ratios in the 4 quadrants. The signs of trig ratios in the 4 quadrants. So let's look at that. Good. So the topic is signs of trig ratios in the 4 quadrants. In the 4 quadrants. So plural, quadrants. Good. So we learned that on the Cartesian plane, we have 4 quadrants. This is the first quadrant, this is the second quadrant, this is the third quadrant, and this is what? The 4th quadrant. So we number in what? An anti-clockwise direction. Good. Now I want to know the trig ratios, the signs. That the focus is on the signs. The signs, whether positive or negative. The signs of the trig ratios in the 4 quadrants. So first we'll look at the first quadrant. The first quadrant. So in the first quadrant, angles there are between 0 degrees and 90 degrees. So we say that they are all what? Acute angles. They are all acute angles. So let's look at it. Good. So assuming our angle here is theta. Okay, we have an angle theta here. Now, to find the trig ratios, we have to get a right angle triangle. I hope you bear with me. Good. We have to get a right angle triangle. So to get the right angle triangle, we have to get a perpendicular line from the terminal side to the x-axis. Good. So let's see. Good. So this will give us what? A perpendicular line. And then the angle here will be what? 90 degrees. So now we have what? Our right angle triangle. Good. Now let's let's use the 3, 4, 5 Pythagorean triplets to get the trig ratios. So if the opposite is 3 and then the adjacent is 4, the hypotenuse will be 5. Okay, I hope you remember. Good. So now, to find sine theta will be equal to what? Opposite over hypotenuse. So which is what? 3 on 5. And then cos theta is what? Adjacent over hypotenuse, which is what? 4 on 5. And then finally tan theta is equal to what? Opposite over adjacent, which is what? 3 on 4. Okay, so let's put the units there. 3 on 4. Good, so tan theta is 3 on 4, cos theta is 4 on 5, sin theta is what? 3 on 5. Good. Now, you realize that they are all positive. They are all positive. I hope you can see that. Good. So what it means is that in the first quadrant, all the trig ratios there are positive. So in the first quadrant, all trig ratios are positive. Okay, we can also put it this way, that the trig ratios of all acute angles are positive. The trig ratios of all acute angles are positive. Okay, good. So in the first quadrant, all the angles there are what? Are acute angles because they are between 0 degrees and what? 90 degrees. So in the first quadrant, all the trig ratios of the angles in the first quadrant are positive. So take note of that. Good. Now let's move on to the second quadrant. The second quadrant. Good. Now here, let's look at something. Good. So this will be our angle theta. Okay, our angle theta. So the angle theta is in the second quadrant, and at this point it is between 90 degrees and what? 180 degrees. Okay, so what it means is that the angle theta is what? An obtuse what? Angle. Okay, an obtuse angle. Now you bear with me that we cannot find, or we cannot get a right angle triangle where one of the interior angles is what? Obtuse angle. Is that okay? So which means that it will be practically impossible for us to find the trig ratios of what? Sine theta. Is that okay? Where the theta is what? An obtuse angle. But there is a way we go about it. Okay? What we do is that we use the reference angle formed by the obtuse angle. So let me take it again. To find the trig ratios of an angle in the second quadrant, we use the reference angle formed by the angle. We use the reference angle formed by the angle. So in the second quadrant, the angle theta forms what? Or has a related what? Angle, which is what? The angle here. Okay, so this angle here, that is the reference angle. So this reference angle is formed by or created by the angle of theta. Now let's label this as R2. Okay, good. So to get the trig ratios of the angle theta, we will use the what? The trig ratios of the what? Its reference angle. But we'll pay attention to the sign of what? Of the axis. Okay? So let me take it again. To get the trig ratio of angles in the second quadrant, we will have to use the trig ratios of its reference angle instead. Okay? Because it is practically impossible to use what? Or to find the trig ratios of what? Of an obtuse angle. So we do that by using the what? The reference angle. So that is what you have to bear in mind. Good. So now we'll have to create a right angle triangle in relation to this what? Reference angle. So we do that by getting a perpendicular line from the terminal side to the what? X-axis. So this is our perpendicular line, and this is what? 90 degrees. I hope you are following. Good. Now using the same dimension as we've been using, the 3, 4, 5 triplets. Now this side of the x-axis, all the values here are negative. So here we'll use -4 for the distance here. And then this side, because it is in the positive y-axis, we use +3. And then the hypotenuse is always positive, so we use 5. I hope you are following. Good. Don't worry, you get it. So now, let's find the trig ratios of the reference angle created by the angle theta. Good. So first of all, look for sine R2. Good. We know that sine is what? Opposite over hypotenuse. So sine R2 will give us what? 3 on 5. Okay, 3 on 5. Good. Now this sine R2, okay, is positive. Okay, and it's in the what? The second quadrant. Now we say that, or we conclude that this sine R2 giving us 3 on 5 is the same ratio as the sine of the theta itself. So sine theta, okay, sine theta is the same as sine R2. Do you get it? Don't worry. If you are not getting, you get. Take your time and follow me. Good. So sine R2, which is 3 on 5, is the same as the sine of the principal angle. Okay, so that is the relationship between the trig ratios of the angle theta, which is what? An obtuse angle, and its reference angle. So the sine of the angle theta, that is the obtuse angle, is the same as the sine of its reference angle. That is what you have to bear in mind. Good. Now let's move on. You get it. So let's find cos R2. So cos R2, we know cos is what? Adjacent over hypotenuse. So what is the adjacent? It's -4. And what is the hypotenuse? 5. Okay? So let's look at something here. We are having cos R2 to be what? -4 on what? On 5. But you know that cos of an acute angle is never negative. Okay? Cos of an acute angle is never negative. Okay? So what this -4 on 5 implies is that it is rather negative of cos R2. Is that okay? So the actual cos R2 is 4 on 5. But the negative here means that we have to attach a negative to R2. So when we put negative in front of R2, it is this rather which will be equal to what? -4 on 5. So what it means is that the 4 on 5 is cos R2, and then the negative is just the sine. Okay? Good. And this negative cos R2 is the same as cos theta. Is the same as cos theta. So what it means is that in the second quadrant, okay, the cos of an angle theta is the same as the negative cos of its reference angle. In the second quadrant, the cos of an angle theta is the same as the negative cos of its reference angle. I hope you are following. Good. Now let's look at tan R2. So tan R2, we know tan is what? Opposite of our adjacent. So the opposite is what? 3. The adjacent is what? -4. But in maths, it is best we write the negative at the numerator side. So we are going to get -3 on 4. Okay. Now here also, tan of an acute angle will never be what? Negative. So what it means is that it is rather negative tan R2, which is equal to what? -3 on 4. Are you okay? Good. So now, the tan of the angle theta is the same as the negative tan of its reference angle. The tan of the angle theta in the second quadrant is the same as the negative tan of its what? Reference angle. I hope you are following. Good. So looking at what we've just done, we can see that sine theta in the second quadrant is positive, cos theta in the second quadrant is negative, and tan theta is also negative. So what it means is that in the second quadrant, it is only sine theta which is positive. The rest of the trig ratios are negative. I hope you are following. Good. So let's move on. Let's look at the third quadrant. Good. Here also, the principal angle theta is this. So this will be our theta. Now our reference angle will be here. So angles that are greater than 90 degrees, we get their ratios using their reference angle. Okay, we get their ratios using their reference angle. So theta, this angle is more than what? Than 180. Okay, so it's a reflex what? Angle. It's between 180 and what? 360. So it's a reflex angle. Good. So now we cannot get a right angle triangle with one of the angles being reflex what? Angle. So what we do is that we use the reference angle created by what? The angle itself. So we use the reference angle created by what? The angle what? Theta. Okay, so here the reference angle is this angle. The angle here. That is between the x-axis and the terminal side. So we can label this as what? R3, okay, as our R3. And we'll need a right angle triangle, so we have to get a perpendicular line from the terminal side to the x-axis. Good, so this is our perpendicular line. Now using the same dimension, this place will be 5, okay, this place will be 4, but it is in the negative x-axis, so we'll put negative 4 there. And then here also it is in the negative y-axis, so we'll put negative 3 here. I hope you are following. Good. So we take into consideration the sign of the axis. So this is the negative x-axis, this is the negative y-axis. So the value here will be negative 4, the value here will be what? Negative 3. Good. So now let's find the trig ratios of the reference angle. So sine R3, you know sine is what? Opposite over what? Hypotenuse. So the opposite is negative 3, the hypotenuse is 5. So we have negative 3 on 5. Okay, good. Now here also, there is no trig ratio of an acute angle that is what? Negative. So what it means is that this is rather the negative of sine R3. That will be what? Negative 3 on 5. So we have to attach negative here, because the sign of an acute angle is always what? Positive. So once we are getting negative 3 on 5, it means that the sine R3 was negated. So we have negative sine what? R3. And this is the same as the sine of what? Of theta. So in the third quadrant, sine theta is the same as the negative sine of its reference angle. Sine theta is the same as the negative sine of its reference angle. In other words, in the third quadrant, sine is what? Negative. In the third quadrant, sine is negative. I hope you are following. Good. So now let's look at cos. So cos R3, we know cos is what? Adjacent over hypotenuse. Now the adjacent is negative 4, the hypotenuse is what? 5. So here also cos R3 should be a positive value, but we are getting negative 4 on 5. So it means that the cos R3 is what? Negated. So negative cos R3. And this is the same as cos theta. Okay, so in the third quadrant, cos theta is what? Negative. I hope you are following. So the cos theta of the principal angle is the same as the negative cos of what? Its reference what? Angle. So you have to take note of this relation. Good. Now finally, tan R3. So we know that tan is what? Opposite over what? Adjacent. So the opposite is negative 3, the adjacent is negative 4. So here, the negative will cancel the negative. We are getting 3 on what? On 4. So here tan R3 is positive. So we leave it as it is, because tan of an acute angle is what? Is positive. So here our tan theta is the same as the tan of its reference angle. Tan theta is the same as the tan of its what? Reference angle. I hope you are following. Good. So we can conclude that in the third quadrant, it is only tan which is positive. The rest of the ratios are what? Are negative. The rest of the ratios are negative. Good. So now, try your hands on the final one for me. Try your hands on the last quadrant for me, and let's see the signs that we'll be getting. So here, the principal angle is from here to here, and then the reference angle is what? Here. The acute angle here. So you need your what? Your perpendicular line from the terminal side, so that you get your what? Your 90 degrees. So we are using the same dimension. This one opposite to be negative 3, because it is in the what? It is in the negative y-axis. Okay, and here it will be positive 4. Okay, so we maintain the positive 4, and the hypotenuse is always positive, so we use 5. And this will be our R4, the reference angle. And then this is our what? Our theta. So the black one is our theta. Good. So let's see. Try your hands. Do it before I do mine. Right. So let's move on quickly. So sine R4. You know sine is what? Opposite over what? Hypotenuse. So the opposite is -3. The hypotenuse is what? 5. So here also, sine of an acute angle is always positive. So once it is negative, it means that the sine R4 should be what? Negated. And this is also the same as sine theta. So sine theta in the fourth quadrant is the same as the negative sign of its reference angle. Move on to cos R4. We know that cos is what? Adjacent over hypotenuse. The adjacent is 4. The hypotenuse is what? Is 5. So here cos R4 is positive. Okay, so we don't need any negative. So what it means is that in the fourth quadrant, cos theta is the same as cos of its reference what? Angle, and it's positive. Then finally, tan R4 is what? Opposite over what? Adjacent. So the opposite is -3. The adjacent is 4. So here, tan R4 is tan of an acute angle. It should be positive. So now that it is negative, it means that the tan R4 should be negated. So we have negative tan R4, and this is the same as tan theta. Okay, so in the fourth quadrant, tan of that angle is the same as the negative tan of its reference angle. So students, this is all about the signs of the trig ratios of the 4 quadrants. The signs of the trig ratios of the 4 quadrants. So let's go back and see what we've done so far. So we saw that in the first quadrant, all the trig ratios are positive. In the second quadrant, we saw that it is only sine which is positive, the rest are negative. And we use the reference angle to get the trig ratios of the principal angle. Here also in the third quadrant, we saw that it is only tan which is positive, the rest are negative. And then finally, we looked at the fourth quadrant and we saw that it is only cos which is positive, the rest are negative. Good. So let's summarize all the signs in a table form for easy understanding. Good. So we have summary of signs of trig ratios. Summary of signs of trig ratios. Good. So we have sine theta here, and at this point, the theta is between 0 and 90 degrees. So it means that theta is in the first quadrant. So we saw that in the first quadrant, sine theta is what? Positive. Cos theta is also positive, and tan theta is also what? Positive. So in the first quadrant, all the trig ratios are what? Positive. Then we came to the second quadrant. In the second quadrant, we saw that it is only sine which is positive. The rest are what? Negative. So when theta is between 90 degrees and 180 degrees, sine will be positive, cosine will be negative, and then tangent will also be what? Negative. Okay, because the theta is what? An obtuse angle. And complete the rest. Do the rest quickly. Okay, so now in the third quadrant, it was only tan which is what? Positive. The rest are negative. And then in the fourth quadrant, cos was positive. The rest are negative. Okay, so we can simply use letters to represent. In the first quadrant, all the trig ratios, all are what? Are positive. In the second quadrant, only sine is what? Positive. In the third quadrant, tan is positive, and in the fourth quadrant, what? Cos is what? Positive. So we have ASTC. Okay, now this one can be better arranged as the caste system. The caste system. So let's see how to get the signs of the trig ratios of the 4 quadrants. in an easy way. Good. So the summary of the signs of trig. So this is what we call the caste system. So the A stands for all. So in the first quadrant, all the trig ratios are positive. In the second quadrant, only sine is what? Positive. In the third quadrant, only tan is positive. And in the fourth quadrant, only cos is what? Is positive. So students, this is where we'll end our lesson. So take your time, go through the video to understand, okay? Good. So till we meet again, revise, read ahead. Bye.